Welcome to Cosmic Compass, where we explore the universe one story at a time. If you've ever looked up and wondered what lies beyond the stars, you're in the right place. Today's journey takes us deep into the heart of Mars, into a canyon so vast it redefines what we think we know about planetary geology. Let's take a moment to imagine this, a canyon so deep it could swallow Mount Everest and still have room to spare. A scar stretching across the face of an entire planet, wide enough to be seen from orbit. This isn't Earth, this is Mars, and the canyon is Valles Marineris, the largest known canyon system in the solar system. For over a decade, the Mars Reconnaissance Orbiter has been circling the red planet, silently capturing astonishing images through its high-rise camera. What it's seen over Valles Marineris is nothing short of breathtaking. In this episode of Cosmic Compass, we journey together through the hidden landscapes of Mars' greatest geological wonder. We'll glide over cliffs, descend into shadows, and uncover mysteries written in layers of stone. What lies at the bottom of a Martian canyon? What can these colossal rock formations tell us about Mars' ancient past? Let's find out. Valles Marineris spans an immense 4,000 kilometres in length and plunges up to 7 kilometres deep. By comparison, it stretches across nearly a quarter of Mars' circumference and dwarfs the Grand Canyon in every dimension. It's not just a valley, it's a planetary wound. The canyon system starts in the west with Noctis Labyrinthus, a chaotic network of intersecting canyons. As we travel eastward, the landscape opens up into wide troughs and chasms, eventually fading into what might once have been a massive outflow channel, a dry riverbed leading toward a vanished ocean. From orbit, the molar altimetry data paints a dramatic elevation map. Bright reds mark towering plateaus, while deep blues signal plunge zones into the Martian crust. These visuals don't just impress, they hint at the violent tectonic and possibly volcanic processes that shape this region, but data can only say so much. Let's change our perspective. Imagine looking across a 5-kilometre stretch of rock, then zooming in to examine just a single kilometre. At this resolution, Mars begins to feel intimate, real. This is where exploration truly begins. As we move closer to the edge, the surface breaks away into a void. The horizon disappears, replaced by shadow. It feels like we're standing on the edge of a forgotten world. Descending the canyon walls, we pass through exposed layers of Martian bedrock, each one a snapshot of time. Some bands are darker, some lighter, others streaked with rust red and pale grey. These aren't just colours, they are the minerals of ancient Mars, oxidized iron, basalt sulfates and clays. What happened here? Did volcanic eruptions paint these bands layer by layer? Did ancient water flow, then vanish, leaving sediments behind? Did ice once press and crack the surface, shaping what we see today? As we scan further, signs of movement appear. Boulders have fallen from high above their paths, etched like scars across the dusty slopes. Some rest quietly at the bottom, while others still cast shadows in motion, as if Mars is not done shifting. Then there's the wind. Even now, thin wisps of atmosphere carve patterns into the dust. We see ripples, erosion, smooth surfaces that speak of a planet slowly sculpting itself. Eventually, the slope eases. We're not at the bottom, not yet, but already we've seen hundreds of millions of years revealed in a vertical tapestry of stone. This canyon isn't just deep in kilometres, it's deep in time. As we continue eastward into Ganges Chasma, the terrain grows even more varied. Sharp cliff faces reveal dark lava flows layered between pale dust solidified streams of ancient basalt now exposed by erosion. These flows tell us Mars was once volcanically active, pouring molten rock across the land. Midway up the canyon walls, bright mineral veins cut across the rock. Some look like they could collapse at any moment, crumbling back into the abyss. Yet above them lie smoother, more resistant bands, possibly ancient sediments, hardened over time. What makes one layer fragile and another resilient? Perhaps it's the presence of water. Maybe in a distant Martian age, these canyons held lakes, rivers. Life, nothing here is random. Every jagged line and subtle curve has a story. And while the wind has been relentless, carving away at the softest rock, the most durable formations remain like bones weathered by centuries. If you listen closely, you can almost hear the silence of this place, the quiet persistence of geological memory. Now we arrive at the base. The floor of Valles Marineris is a desert, but unlike any desert on Earth. Here sand dunes stretch across the basin, shaped by winds that have blown for millions of years. But this sand is different. It's darker, denser. Rich in iron and magnesium, it absorbs more sunlight and offers no sparkle. If you reached down and ran it through your fingers, it would feel heavier, sharper, forged from volcanic rock rather than worn down quartz. In Noctis labyrinthus, we encounter a strange green tint on the ground. Scientists believe this is due to clay minerals, perhaps remnants of an environment where water once pooled, seeped, and altered the landscape chemically. Craters and troughs collect the sand like bowls catching snowfall. Some even show layers of dark minerals capping lighter dunes, creating textures that feel both alien and familiar. What would it be like to stand here in silence, surrounded by towering cliffs and shifting dust? You might feel awe or isolation, or both. Either way, you'd be walking on Mars's ancient memory. Amid the dunes and eroded walls, we find mesas, flat-topped islands of rock that once were part of a larger unified surface. Now they stand alone, slowly shrinking under the Martian wind. Around them, light-toned patches of hydrated minerals hint at something remarkable, the past presence of water. These aren't ice caps or frozen lakes. They're minerals that have bonded with water molecules, molecular fossils of Mars' wetter days. Nearby volcanic regions could have melted underground ice, producing short-lived flows. Those flows might have soaked the soil, reacted with the crust, and vanished, leaving behind a chemical trace. Even more striking are the folded rock patterns found in Valles Marineris. They ripple like cloth, curled and warped. On Earth, such folds form deep underground under heat and pressure, but here they lie exposed. Were these rocks once soft, wet, icy, and did erosion gradually peel back the surface to reveal this strange formation? The deeper we go, the more Mars challenges our assumptions. Every formation is a question. Every question pushes us further. Before we leave this ancient canyon, let's pause. Imagine looking across a Martian valley where sunlight slices through dust-filled air, casting long shadows across the red floor. A small mountain range rises steep, jagged, silent. It towers with no trees, no sound, no life. And yet it speaks. It tells us that planets change, that Mars, once turbulent and warm, has become still and cold, that the universe doesn't just destroy it, records. In Valles Marineris, we don't just see rocks, we see memory. We see stories told in sediment and silence, and for all we've uncovered, there's more left hidden. More questions to ask, more horizons to reach. So as we depart, let's carry with us not just data but perspective. The canyon is behind us, but the journey is far from over. Thank you for travelling with us through Valles Marineris. If this journey inspired you to look at Mars a little differently, consider subscribing to Cosmic Compass. Here, we turn space into story one breathtaking world at a time. Leave a comment. What would you want to explore next? Olympus Mons, Europa. The edge of the solar system. Your curiosity fuels this channel. Until next time, stay curious, stay cosmic. You've been watching Cosmic Compass. For more stories from across the stars, subscribe and hit the bell icon. The cosmos is calling and we're here to help you answer.